Good afternoon, everyone, especially to my teacher, Mr. Fernando Tangin. By the way, I'm Richard A. Dalangin, a third-year BSS student at University of the Visayas, Toledo City campus. So I am here today to discuss about data analysis process. So data analysis process. When you have a good understanding of a phenomenon, it is possible to make prediction about it. Data analysis helps us to make this possible through exploring the past and creating predictive models. So the data analysis process is composed of the following steps. So first is the statement of problem. Next is obtain your data, then clean your data. Next is normalize the data, then transform the data. Next is exploratory statistics, then exploratory visualization. Then next is predictive modeling, then validate your model. Next is visualize and interpret your result, and last is deploy your solution. So next is the problem. So the problem definition starts with high-level question such as how to track differences in behavior between groups of customers, or what's going to be the goal price in the next month. Understanding the objectives and requirements from a domain. Perspective is the key to a successful data analysis project. So there are 6 types of data analysis question. First is the inferential. So inferential questions will be a statement of this proceed hypothesis as a question and would be answered by analyzing a different set of data, which in this example is a representative sample of adults in the US. So next is the predictive question. So predictive question will be one where you ask what types of people will eat high in fresh fruits and vegetables during the next year. In this type of question, you are less interested in what causes someone to eat a certain diet, just what predicts whether someone will eat this certain diet. For example, higher income may be one of the final set of the predictors, and you may not know or even care why people with higher incomes are more likely to eat high in fresh fruits and vegetables. But what is most important is that income is a factor that predicts this behavior. So next is the descriptive question. So descriptive question is one that seeks to summarize a characteristic of a set data. Example include determining the proportion of males, the mean number of serving of fresh fruits and vegetables per day, or the frequency of viral illnesses in a set of data collected from a group of individuals. There is no interpretation of the result itself, as the result is a fact, an attribute of a set data that you are working with. So next is the exploratory. So exploratory question is one in which you analyze the data to see if there are patterns, trends, or relationship between variables. These types of analysis are also called hypothesis generating analysis, because rather than testing a hypothesis as would be done with an inferential, um, causal, or mechanics question. You are looking for pattern that would support proposing a hypothesis. So next is the causal question. Causal question asks about whether changing one factor will change another factor. On average, in a population, sometimes the underlying design of the data collection by default allows for the question that you ask to be causal. So next is the correlational. So correlational is a type of method that involves observing two variables in order to establish a statistically corresponding relationship between them. The aim of correlational is to identify variables that have some sort of relationship to the extent that a change in one creates some change in the other. So data preparation is about how to obtain, clean, normalize, and transform the data into an optimal data set, trying to avoid any possible data quality issues such as invalid, ambiguous, out of range, or missing values. This process can take a lot of your time. In chapter 2, working with data, we go into more detail about working with data using OpenRefine to address the complicated task. Analyzing data that has not been carefully prepared can lead you to highly misleading results. So the characteristics of good data are listed as follows. First is the complete, next is coherent, then unambiguous, next is countable, next is correct, then standardized, next is non-redundant. So next is the data exploration. So data exploration is essentially looking at the data in a graphical or statistical form, trying to find patterns, connections, and relation in data. Visualization is used to provide overviews in which meaningful patterns may be found in Chapter 3. Data visualization, we present a visualization framework or D3.GS, and so D3.GS, also known as D3, short for Data Driven Documents, is a JavaScript library for producing dynamic interactive data visualizations in web browsers, and we implement some examples on how to use visualization as a data exploration tool. So next is predictive modeling. So predictive modeling is a process used in data analysis to create or choose a statistical model trying to best predict the probability of an outcome. In this book, we use a variety of those models, and we can group them in 3 categories based on its outcome. Another important task we need to accomplish in this step is evaluating the model we choose to be optimal for the particular problem. The no pre-lunch theorem proposed by Wolpert in 1996 stated, no pre-lunch theorems have shown that learning algorithms cannot be universally good. So the model evaluation helps us to ensure that our analysis is not over-optimistic or over-fitted. In this book, we are going to present two different ways to validate the model. First is the cross-validation. We divided the data into subsets of equal size and test the predictive model in order to estimate how it is going to perform in practice. We will implement cross-validation in order to validate the robustness of our model, as well as evaluate multiple models to identify the best models based on their performance. Second is hold out. Mostly large data set is randomly divided into three subsets: training set, validation set, and test set. So next is visualization of result. This is the final step in our analysis process, and we need to answer the following questions: how it is going to present the results. For example, in tabular reports, 2D plots, dashboards, or infographics, where is it going to be deployed? For example, in hard copy printed or poster, mobile devices, desktop interface, or web, each choice will depend on the kind of analysis and particular data. In the following chapters, we will learn how to use standalone plotting in Python with Plotlib and web visualization with D3GS. So next is the quantitative versus qualitative data analysis. So quantitative and qualitative analysis can be defined as follows. Quantitative data, it is numerical measurements expressed in terms of numbers, while the qualitative data, it is categorical measurements expressed in terms of natural language descriptions. So the differences between quantitative and qualitative analysis: quantitative has structured data, while the qualitative has unstructured data. In quantitative, has statistical analysis, while in qualitative has summary only. And in quantitative has objective conclusions, while the qualitative has subjective conclusions. So quantitative analytics involves analysis of numeral data. The type of analysis will depend on the level of measurement. There are four kinds of measurements: the nominal, the ordinal, the interval, and the ratio. So nominal data has no logical order and is used as classification data. And then ordinal data has a logical order and differences between values are not constant. Then the interval data is continuous and depends on logical order. The data has standardized differences between values but does not include zero. Then the ratio data is continuous with logical order as well as regular interval differences between values and may include 0, Qualitative analysis um, can explore the complexity and meaning of social phenomena. Data for qualitative study may include written text, for example, documents or email, and or audible and visual data, for example, digital image or sounds. In Chapter 11, Sentiment Analysis of Twitter Data, we present a sentiment analysis from Twitter data as an example of qualitative analysis. That's all.